The next section introduces the concept and basic process of machine learning. This section introduces the basic knowledge of machine learning and the key steps of a machine learning project. Machine learning is an interdisciplinary subject involving probability theory, statistics, approximation theory, convex optimization, algorithm complexity theory, and other disciplines. Here are some existing definitions of machine learning. The first is author Samuel's definition of machine learning that gives computers the ability to learn without being explicitly programmed. Samuel also invented the term machine learning and contributed towards one of the most influential ideas in the field, a method called temporal difference learning, now a bedrock of the field of reinforcement learning. The earliest experimental work on machine learning was by author Samuel on a program that learned to play the game of checkers by purely self-play, and it was an astonishing feat done in the late 1950s on a vacuum-tube IBM 701 computer. See the picture below. It's hard to match Samuel's audacity since the computers were hardly easy to program, as there was no computer display terminals, no modern programming languages. Everything had to be coded in assembly, and all one had was some blinking lights. Even today, Samuel's achievement is hard to match, and it's arguable that Samuel's achievement single-handedly created the modern experimental field of machine learning. Here is an updated definition from Tom Mitchell. While post-learning problem, a computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T, as measured by P, improves with experience E. T refers to the task to be completed, E refers to experience, and P refers to the indicator of task performance. Take training a spam recognition model as an example. You may mark some emails as spam on a daily basis. According to your marks, the mailbox may learn how to mark spam more accurately. According to Tom Mitchell's definition of machine learning, please give the definitions of E, T, and P. E is watching your label emails as spam or not spam. T is classifying emails as spam or not spam. And P is the number of emails correctly classified as spam, not spam. After understanding the definition of machine learning, we will introduce the basic process of machine learning. The key steps of machine learning process are collecting the data, training the model, evaluating model, and deploying the model. Machine learning problems start with data, preferably lots of data for which you already know the target answer. Data for which you already know the target answer is called labeled data. In supervised machine learning, the algorithm teaches itself to learn from the label examples that we provide. Each example observation in your data must contain two elements: the target, the answer that you want to predict. You provide data that is labeled with target to the machine learning algorithm to learn from. Then you will use the trained machine learning model to predict this answer on data for which you do not know the target answer. Variables features. These are attributes of the examples that can be used to identify patterns to predict the target answer. For example, for the face recognition problem, dataset is face image with the name label. Then you are now ready to provide the machine learning algorithm with the training data. The algorithm will learn from the training data patterns that map the variables to the target, and it will output a model that captures these relationships. The machine learning model can then be used to get predictions on new data for which you do not know the target answer. Similarly, taking face recognition as an example, using the collected data to train the model can make the model from unable to recognize the face correctly to recognize the face correctly. The next step is to evaluate the model. The standard of model evaluation is the generalization ability of the model. Two criteria to measure generalization ability are error and fitting. Whether to fit is divided into underfitting, fitting, and overfitting. As we can see from the figure, the value of vertical axis tends to be stable with the increase of horizontal axis value. The curve fitted in the first graph is linear correlation between the horizontal axis and the vertical axis, so it does not fit the training data well. which is called underfitting. The second graph has a good fitting effect and becomes a fitting. Although the curve in the third graph passes through most of the points in the graph, its fluctuation is too sharp, so its fitting effect is not good, which is called overfitting. The last step is to deploy the model. That is, to deploy the model to the actual production scenario. This part of content is mainly related to the project implementation. It is result-oriented in engineering, and the effect of model running online directly determines the success or failure of the model. It not only includes the accuracy and error, but also the speed, resource consumption, and stability of its operation. Thanks for your watching.